Hi, welcome to Rewodu. It's Physics, Units and Measurements, Part 2, Conversion of Units. In the last lecture, we talked about measurements and its importance in science. We also talked about unit. The physical quantities in physics can be divided into two groups, fundamental or base quantities and derived quantities. And their units are called fundamental units or base units and derived units. Base units and derived units are collectively called system of units. System of units have three popular obsolete system of units which are known as CGS centimeter gram second, FPS foot pound second system, and MKS meter kilogram second system. Presently, we use this SI units of system, which is also known as metric system. The seven base quantities and their units in SI system of units are these: length, mass, time, electric current, temperature, amount of substance, luminous intensity. All other physical quantities can be derived from these quantities and so their units. Like in the last class, we derived units for speed. Speed, which is distance upon time. So distance has units of meter and time as second. So the unit of speed is meter per second, or we can write it as meter per second like this, in line. This is the preferred way of writing units, inline units. Like speed, other physical quantities can be derived from fundamental quantities and their units. Like if you want to know the units of density, so the density is mass divided by volume. In order to find the units for density, we must know the units of mass and volume. We know the mass has units of kilogram, but what about volume? So volume is some constant C into length into length into length, some form of length. Like for cylinder, volume of cylinder is pi radius into height of the cylinder. So the volume of any object is some constant into length cube, length into length into length, some form of length. Okay, so the unit for volume is, constants don't have any units, they are constant. So units must be, for r or for any length, is meter into meter, it's meter cube. Similarly, if you want to know unit for area is some constant length into length, like of circle, pi r square. Pi is constant, r into r. So unit for area is meter into meter square. These are SI units. Okay, so for density is mass upon volume. So for units, mass has units of kilogram and volume meter cube. Density is represented as rho, Greek letter rho. So units of density is kilogram meter cube. Okay, now coming to the main part of this video, which is conversion of units. Conversion of units. We know the units for speed is, we know the unit of speed is meter per second. Now, if you are given speed as, if you are given speed as some speed v as 50 kilometer per hour, but we know in SI systems speed must have units of meter per second. Here it's kilometer per hour, so we need to convert this kilometer per hour to meter per second. How can we do it? It's very easy. We write 50 kilometer hour and we multiply it by 1. Okay, it's fair mathematically. So 50 into kilometer hour. So instead of 1 we can write here as 1000 meter and 1 kilometer, and because 1 kilometer is equal to 1000 meter, they can get cancelled and answer would be 1. So it's perfectly legal to write like this. Similarly for hour, I can write here 1 hour and divided by 3600 seconds. 1 hour is equal to 3600 seconds. 1 hour is equal to 60 minutes and 1 minute is 60 seconds. So 60 into 60, 3600. So this hour will be cancelled by this, and this kilometer can be cancelled by this. So it will become 50 into 1000 divided by 3600, this meter and this second. So 500 divided by 36 meter per second, which is roughly equal to 13.889 meter per second. So how did we do it? We divide this unit by 1 of that unit and convert 1 of this unit to SI unit similarly of hour, like this. Okay. Now we'll try to do this one more question. Suppose if you are asked to find the density rho for a body who has mass, for a body with mass equal to 10 megagrams, okay, and volume equal to 200 millimeter cube. Okay, now you have to find the density in SI units. So how can we do this? We write rho is equals to mass upon volume, where mass is given as 10 megagrams upon volume, which is 200 millimeter cube. But we know that the unit for density is kilogram per meter cube. We just did that. Okay, so we must convert these units to kilogram per meter cube. So just like we did above, we can multiply by 1, 200 millimeter cube. We first divide by this unit 1 megagram, and to balance it out we must write the unit which is required by SI units, which is kilogram. So if we want to convert 1 megagram to 1 kilogram, so mega is 1000 times of kilo. You can check it in the prefixes. So it's 1000 kilogram, okay, into, here should be 1 millimeter cube, and 1 millimeter of cube should be balanced here, so that we get 1 here. So how can I convert 1 millimeter to 1 meter? 10 to the power minus 3 meter is 1 millimeter, and cube of that. Okay, now we can erase this. 10 megagram 200 millimeter cube, 1000 kilogram divided by 1 megagram, 1 millimeter cube into, when the base is same, and when the base is same, power gets multiplied. So 10 to the power minus 9 meter cube. Okay, this gets cancelled, this gets cancelled. So what we are left with, 10 into 1000, 10 into 1000 kilogram, and 200 into 10 to the power minus 9 meter cube. So the answer will be 10 to the power 4, 2 into 10 to the power 2 into 10 to the power minus 9 kilogram per meter cube, 5 into 10 to the power 10, very high density. Okay, let's do one more question. The question is, kinetic energy of any object is given as half times mass times velocity squared. Okay, so first you have to find the units for kinetic energy in SI units, and then you have to do this question. Find kinetic energy of a body moving with 30 meter per minute. Mass of body is 3 gigagrams. Okay, so pause the video and try to do it yourself. Okay, let's do it. We know the units for mass, the unit of mass is kilogram, and unit for velocity is meter per second. Okay, and constant doesn't have any unit. So the units for kinetic energy will be kilogram into velocity squared, so meter so the kinetic energy has units of kilogram meter square per second square. This is the unit for kinetic energy, and for any energy for that matter. Because energy is a very common physical quantity and we encounter it many times in physics, instead of writing like this, we named this unit as joules. So the unit for kinetic energy is joules, or you can write it like this also. Both are correct. 1 joule is equals to 1 kilogram per meter square, 1 kilogram meter square per second square. Okay, now coming for the next part of the question. We are given mass as 3 gigagrams. 3 gigagrams. Okay. Giga is 10 to the power 9 grams. And in SI units, mass has units of kilogram. So we can write this as 10 to the power 6 into 10 to the power 3. And from the prefix table, we know that 10 to the power 3 is kilo. So 3 into 10 to the power 6 kilogram. So we got our mass in kilograms. Now we must find velocity in meter per second. Velocity is given as 30 meter per minute. Okay. Velocity 30 meter per minute. Numerator is correct, but we must convert minute to second. 30 meter minute. To balance it out, 1 minute here, and to balance this out so that we get 1 here, 60 seconds. Minutes gets cancelled. So velocity is 30 divided by 60 meter per second, which is 0.5 meter per second. So kinetic energy is half mass is 3 into 10 to the power 6. 3 into 10 to the power 6, and velocity is 0.5 square. So kinetic energy comes out as 0.375 into 10 to the power 6 joules. And from prefix table, we know that 10 to the power 6, we can also write it. Okay, and from so the answer is this. Okay, and suppose you don't want to write 10 to the power 6, what you can do, from the prefix table, you know that 10 to the power 6 is mega, so you can write this answer as mega joules. Both are correct.